Welcome back to my channel, everyone. Sri Tips here, and this is some gold that Mrs. Sri Tips has recently purchased, and this is all 14K stuff. Those little ones, I don't care about those little ones. I don't save those. This is 18K gold here, so we put that in the 18K gold bin. This is some more 14K stuff. These kinds of earrings here, they're sealed up, so I cut them in two because they like to explode as they're being heated in the crucible. Save that little catch. I'll put those up and save them. The rest of it goes into the 14K bin over here. Save the little stuff, the little clasps and earrings and stuff like that, and clean this up and save it, and either resell it or put it away for a rainy day. You can zoom in on that so you can see the marking. It says 1/20th 12K, I believe. For these gold filled chains, what we'll do is just got a bag of gold filled stuff, and I just throw it in here, and then when I get enough material, I'll do a refining on this. Put a crucible up here, zero it out, get a weight on our 14K material. Looks like we've got 37.1 grams of 14K. No 10K this time around. I've got some 18K stuff here. Add that to the crucible, and that looks like 7.2 grams of 18K. And we'll take this out, put it on the melt table, melt it up, and add some silver to unquart this gold. But you can see I've calculated that we need 60 grams of sterling silver to unquart our gold. Estimated yield from this group is going to be 27 grams. And I've got some gold here, or silver, 60 grams. So what we'll do is we'll take this out. We'll put it on the table. We're going to add this silver to the molten gold. That's what I'm going to try to avoid. See our blob of metal. I'm gonna throw a little borax on there. Boom, boom, boom. Look at that. Borax just pulls the junk that's floating on the surface off to the side. Stir this up with a graphite rod. Let's move it over here. I'm going to pour this now into some water. See if we can get some shot. Cornflakes, actually. This is our unquarted gold. Get this out of this container into a beaker. Start pulling the silver and the base metals out with nitric acid now. Here's the unquarted gold. What we're going to do now, got some used nitric acid from a previous refining. I'm going to add a little bit of this to our unquarted gold. We're going to start pulling the silver and the base metals out of here with this used dilute nitric acid. And this will be the first nitric acid boil. I'm not going to show each one. The next time we come back to do the video, to continue the video, all the silver and base metals will be pulled out of here. I empty that liquid into this silver jar and save it because it's going to have silver in it. When we come back, we should have all that pulled out after about 4 or 5 nitric boils. We pulled all the silver, all the base metals out of here with nitric acid boils. So now I'm going to pour off this liquid. It's a yellow color, as you can see. That's probably because we put a little bit of gold in solution. Boiling nitric acid will dissolve traces of gold. So now what we'll do, here's our gold down in the bottom of the beaker. We'll dissolve this in some aqua regia. I'm adding hydrochloric acid. This is about just under an ounce of gold, so we're going to go with about 150 milliliters of hydrochloric acid. Now we'll add some sulfuric acid to precipitate out any lead that may be present. I think for this much gold, expecting 27 grams, let's go with 5 3 milliliter doses of nitric acid. And now what we'll do is set this up on the heat and begin dissolving the gold in aqua regia. Got all the gold to go in solution. It's looking pretty good just for a single recovery with inquartation and parting with nitric. Nice and clear. We'll just let this cool off for a minute. Let's add a little bit of ice here. Get this cooled off so that we can filter it. Let's go ahead and filter our gold solution. There's a little bit of trash in there. And as you can see, the solution looks little on the cloudy side. So what we'll do is we'll try pouring it back through the same filter a second time. Now that this filter is loaded up, it will be able to filter out finer particles that are suspended in our gold solution. Alright, we've got all that pulled through the filter. There was some trash in there, as you can see. And I'm not going to rinse that filter. What we'll do is we'll rinse it out later on, because I don't want to wash through any of the contamination that's in the filter down into our gold solution. Still a little on the cloudy side. I'm going to go ahead and just do a precipitation right now. This is only about 27 grams. What we're going to do is add some sodium metabisulfite and precipitate out the pure gold now for this first refining. That should do it. Now let's pull this filter back up. Still got some gold in it. And we're going to rinse the filter out now and recover that gold. And then what I'll end up doing with this is just adding it into the stock pot. Now let's get rid of this funnel here. Take this, just have a little gold in it, and we'll add this to our temporary waste container and save it. We'll recover the gold out of there later on. Had a little gold in the bottom of this container as well, and I dissolved it out with a little bit of aqua regia. Put that in our waste container. We can get this gold out of this waste container later on. I've allowed the gold to settle for about half an hour. Settled out pretty good in there. Now what we'll do, so we're going to pour off this waste, and I'm going to start rinsing over and over with some water and acid. Let's go ahead and put this up on some heat now. I'm going to add some hydrochloric acid to this. Put it up on the heat and let it boil in hydrochloric acid. That hydrochloric acid cleaned up the gold for us. Looks nice caramel brown color now. What we'll do is go ahead and pull this off of here and dump off this waste solution. Look at that. Nice brown color. Put a little bit of gold in solution, looks like, from the yellow color. Stuff just really looks really, really good. Alright, here's what the gold looks like now. Nice, pretty brown gold. I'm adding some hydrochloric acid. Now we're going to add a little bit of sulfuric acid. Just to make sure if there's any lead in here that made it this far. We're going to get it out of there. Now we're going to put some nitric acid in here. We'll start out with 4 3 milliliter doses of nitric acid. Now we'll cover this up, stick it up here on the heat, and dissolve the gold a second time. That only took about 10 minutes. Got everything to go into solution now. I love that dark orange color of our gold chloride solution. Pull it down, let it cool off a little bit here. Got a little bit of fumage going on in there, not much. So there's probably a little bit of excess nitric in this solution. A little bit of excess nitric. It's not a big problem. Go ahead and cool this off now with some ice. Got this cooled off now. Let's go ahead and pour it through our filter. Even though it probably doesn't even need it, man. That solution is crystal clear. Looks like we got a little bit more junk in the filter, which is a good thing. This looks real good. Got a squeaky clean beaker right here. Let's get rid of our funnel. You can see there's some gray material down in there. Put that in our paper storage. Here's our solution. Nice and crystal clear. Every time we dissolve the gold and reprecipitate, it gets cleaner and cleaner every cycle we do that. Now let's go ahead and put some sodium metabisulfite in here. Precipitate out pure gold. Here we go. Nice. Should do it. Add another half a spoon here. Yeah, there's our white foam. That's it. We're precipitated. I've allowed the gold to settle completely. It's been boiling in hydrochloric acid for about a half hour now. Not half hour. About 10 minutes. You can see the gold looks really, really good. And what we'll do is pour this off now into our waste container. Okay, our gold is nice and clean now. Now let's transfer the clean gold into a clean dish here. It's just a Pyrex dish. And we're going to dry this out so that we can get a weight on it. Get some of that water out of there. This up on the heat and start drying it out. While I'm waiting for the gold to dry out, this is page 278 of C.M. Hoke, Refining Precious Metal Wastes. This is called the Wowell process, and this is the anode, the gold anode that we've prepared that we'll be using in the electrolytic gold cell. A couple of parameters here. Cathode starting sheets of fine gold rolled to a thickness of 0.003 inches. And then we're not going to use that. What I have here is a titanium spacer out of a turbine. I bought 2 of them. And this is titanium, and I've just bent it so that it fits in my 250 milliliter beaker. And this is what we'll use for the electrolytic gold cell. There's a couple of more parameters we're going to use here. We're going to use a voltage of 1.5 volts. We're going to use a gold chloride solution that is 80 to 100 grams per liter of gold, and that's why we're refining this gold in this video. We're going to use that gold as our electrolyte for the electrolytic gold cell. It says here to maintain the operating temperature of 140 degrees Fahrenheit. And then if you look down here, the anodes are corroded. The pure gold plating out on the cathode, which, like I said, we're going to use a titanium blade as the cathode. And the pure gold will plate out on the cathode in a somewhat nodularized crystalline deposit, which adheres firmly. Here's our pure gold powder that we've dried out, allowed it to cool off. It looks spectacular. Nice and clean gold in there. And I've written the weight of the container on the side here. Let's put it up here and see what we got. We've got 425.3 minus 399.7. So we've got 25.6 grams of pure gold in here. So if we dissolve the gold in here, 25.6 grams, and then evaporate it down to 200 milliliters, because that's the size of my cell, that is 1/5 of a liter. The specified amount is 80 to 100 grams per liter. So 1/5 of a liter. So if we multiply this times 5, is that right? Times 5, that should give us the equivalent to 128 grams per liter, which is higher than the recommended amount. But I'm not worried about that. I'd rather go a little higher and get a good result. So we'll redissolve this now. Let's transfer our pure gold powder into this beaker. And now what we'll do is add about 100 milliliters of hydrochloric acid. Set this up on the heat. Alright, now what we'll do is add a couple of droppers of nitric acid and redissolve the gold. Trying to use minimal nitric acid here to get this gold to go into solution. This is perfect. We've got all of the gold dissolved in minimal nitric acid in aqua regia. So what we'll do is we'll set this back here. Look at that beautiful crystal clear orange gold chloride solution. Let's set this back here and let it cool off naturally. So now we've got 25 grams of pure gold dissolved in this liquid, and we can adjust the liquid level with water to get the proper concentration for the electrolytic gold cell. Let's take a look at the electrolytic silver refining cell. It's been in operation for about 5 days. You can see the electrolyte level is getting a little low. So I've got some silver nitrate electrolyte here. I'm going to add a little bit of the electrolyte to bring the actual physical level back up, and this will also augment the silver concentration inside the cell. Let's lift this up and get a peek in here and see what this looks like. This is 5 days of operation. Oh my, beautiful high purity silver crystal. I keep this opening covered with a piece of paper towel to keep any dust from getting down in there. Let's I'm going to take the anode bar out, and I've got some impure silver here. Go ahead and add some of this to the anode basket. Put the anode back in place. And now we've got silver cell maintenance done for this period. And that stuff looks good down in there. Alrighty. This will conclude part 1 of the electrolytic gold refining process, the Woolwill process. We've got the electrolyte made. Stay tuned for part 2. Thank you for watching.